Nice to be indoors and not have to be out.
Yeah, I was just out there and it was pretty cold.
Oh, it is. It's amazing. I have to go out actually for one session tonight, but it's not very far away. Hopefully my car won't get too cold. So what are we working on tonight?
Basically same thing as last time, so a lot of the unit circle stuff.
Okay. Do you have specific stuff?
Yeah.
Okay.
I have it here. This is a multiple choice with a triangle that has sides 96, 28, and 100. And says find the exact value of the indicated trigonometric functions with sine and tangent.
What were the dimensions again of your triangle?
28, 96, and 100.
Okay. We don't really care if it's a right triangle.
Yeah.
And, well, actually we do.
And the angle that we're finding it is adjacent to the 96 side.
This one here?
Yeah.
Okay. Well, first of all, is that a right triangle?
Yeah.
It is a right triangle?
Well, I guess, yes, they have the right triangle, the right angle.
Okay. Okay. Well, that makes a lot of difference. Okay, now we can apply all the trig functions to it.
Yeah.
So tell me what the sine of theta is.
Sine of theta would be opposite over hypotenuse, so 28 over 100.
Which reduces to 7 over 25. Okay. What's cosine of theta?
Cosine of theta would be 96 over 100.
Which reduces to 24/25, I believe.
Mm-hmm.
Tangent of theta.
Tangent of theta would be 28 over 96.
Which is 14 over 48, which is 7 over 24. Okay?
Yeah.
What is the cotangent of theta?
That would be 24 over 7.
What is the secant of theta?
Secant would be 25 over 24.
And finally, the cosecant of theta.
25 over 7.
Uh-huh. Okay. That's good. You know SOHCAHTOA and you know your reciprocal relationships. That's big.
Yeah.
Okay. What else?
If cosecant of theta is 9 over 2, then cotangent of theta is
Okay. Whenever you get problems like this is kind of the quintessential trig problem, where they give you one trig function and they want you to come up with the other 5. And we can do that. The way you do it is always to start out by drawing the triangle, a right triangle, and labeling theta.
Yeah.
Now, what else can we label on this triangle?
Well, cosecant, so it's hypotenuse over adjacent. So,
Hold on, it's hypotenuse over opposite.
oh yeah, because it's sine.
Right.
Yeah. So it would be 9 is the hypotenuse, and then 2 is the opposite side.
Once you've put 2 dimensions on this triangle, you can figure out the third dimension. What is this dimension here?
Square root of 77.
Now, you can tell them what the cotangent of theta is.
Mm-hmm.
What is it?
So would it be? It would be square root 77 over 2.
Uh-huh. And in fact, once you have all 3 sides labeled, you could give the trig function, any of them, of theta. In other words, sine of theta is 2/9, cosine of theta is root 77 over 9, so forth and so on. Now, the way this problem is usually done, let me give you a slight variation of it. And it will say this.
Yeah.
In other words, it will specify which quadrant we're in. What quadrant is that?
Oh, I don't know.
Okay, if we look at our unit circle, this is 90 degrees or pi over 2. This is 180 degrees or pi.
So would it be the first quadrant?
No, it's greater than pi over 2, but less than pi.
Oh, so then it would be in the second quadrant.
Okay, so that information says second quadrant. And now they give you the exact same question. What is the cotangent of theta equal to?
Yeah.
Well, you do the problem exactly the same, only once you come up with your numerical value, you have to make sure you attach a plus or minus sign correct for the quadrant. So what was the cotangent again? What was the numerical value?
Cotangent, wasn't it? Yeah, root 77 over 2.
Now, because it's in the second quadrant, what is the plus or minus sign on it?
It's on cosine?
All students take calculus.
Oh, so it's on the sign.
So only sine and its reciprocal are positive, and its reciprocal is cosecant. So cosecant, that's why it was positive. But what's cotangent in the second quadrant?
Well, then it would be negative.
There we put the sign on.
Yeah.
And that's the best way to do these problems. In other words, adding this extra feature of which quadrant it's in merely gets you to attach the proper sign to that. Doesn't change anything else about the problem. In other words, they were treating it like everything was in the first quadrant.
Yeah.
They essentially were calling this the problem. And what is the cotangent of theta? If cosecant of theta is 9/2, well, if everything's in the first quadrant, it's relatively straightforward. But if we make theta in the second quadrant, it still is relatively straightforward. We still get exactly the same number, only we have to make sure we get the right sign on it.
Yeah.
If it's in second quadrant, cotangent's negative in the second quadrant. Okay, what else you got?
Solve the equation log 3x equals log 5 plus log x minus 2, and we're assuming log is base 10.
Did I do that right?
Yeah.
Okay. So what is log of 5 plus log of x minus 2 equal to?
Log 5x plus 10, or minus 10.
Now what can I say?
Could you raise both sides to 10?
Well, you could do that, but it's not necessary. In other words, once you get the log same base of something is equal to the log same base of something else, now you can equate the arguments. That if that's a true statement, then 3x has to equal 5x minus 10.
Yeah.
Which means what?
X is negative 5?
Positive 5.
Oh, yeah.
In other words, I'm going to move the 3x to the right, leaving 2x over here. I'm going to move the minus 10 to the left, and now x equals 5.
Yeah.
Now, whenever you're solving log equations, make sure you go back and substitute it, and make sure you're not violating any domains. Well, x equals 5 doesn't violate anything. I can substitute 5 for there. I'm taking the log of 15. I can substitute 5 here. I'm taking the log of 3. If you are violating any domain from the original function, then it's not a valid solution.
Yeah, it's extraneous solution.
Correct. And log equations have a lot of extraneous solutions. This is a rare one that does not have one. Usually you get two solutions. You end up with a quadratic and you factor it and you get two solutions, and the negative one usually is extraneous and the positive one is valid.
Yeah.
That's more typical. What else? It's a mixture of stuff. It's not all just trig. It's trig and logs. This must be like a semester review, or?
I don't know. I think it was like a combination of 2 units, because I feel like my teacher's kind of rushing a lot.
Uh-huh. It's not often I get a session where somebody wants to cover trig and logarithms at the same time. They usually are separate.
Yeah. Okay, a building has a ramp to its front doors to accommodate the handicapped. If the distance from the building to the end of the ramp is 14 feet, and the height from the ground to the front doors is 8 feet, how long is the ramp?
Is that a fair picture?
Yeah.
What's x?
It would be 64 plus 4.
Always start out x as the square root of.
Oh, yeah.
Anytime you are solving a right triangle, start out your answer as the square root of. Because it doesn't matter whether you're solving for the hypotenuse or one of the sides. The answer is always square root of. In this case, it's 8 squared plus 14 squared. Whatever that number is equal to is your answer. Funny, I had this problem before. Did we do this problem last week?
I don't think so.
Wow, I must have had it. You go to East?
Yeah.
I have another student that I believe goes there. But it was exactly the same problem. Yeah.
Who is it?
Well, you know, her name's Mina. Mina, M-I-N-A-H. But I don't think she goes to East. I think she goes to that STEM school that's in Northeast Denver. I don't even know I don't remember the name of it. But I don't have that many students from that part of town. And somebody gave me this problem, this exact problem, recently.
Really?
Yeah, that's how I was able to draw it so quickly, as I recognized it.
Yeah.
All right, what else you got?
Well, that was all I had because I don't know, I haven't had a math class since Friday.
Ah.
So we just finished the review packet that he gave us.
All right, let me test you a little bit.
All right.
Tell me the sine of 210 degrees.
It would be these.
Without a calculator, obviously.
I don't know.
Okay, let's go through the process as how we're going to figure it out.
Yeah.
First of all, we need to know what quadrant that's in.
That would be the third, or
Okay.
yeah.
If it's the second, the whole name of the game here is to figure out what the equivalent first quadrant angle is.
Oh, then that's equivalent to sine of 30.
Okay. What's sine of 30 equal to?
It's opposite, so it would be root
Look at my triangle.
1 over
Look at my
1 over
triangle
2.
in the upper left.
Is it 1 over 2?
Uh-huh. These two triangles that you've been studying for 3 years in some form or another,
Yeah.
there's a reason. It's because they're critical for trig even. So if the sine of 30 is equal to 1 over 2, what is the sine of 210 equal to?
1 over 2, but
What's
it would
the
be
plus
negative.
or minus sign on it?
It would be negative 1
Correct.
over 2.
Correct. So that's how you do it. You figure out what the number is, and then you attach the proper sign to it.
Yeah.
So what's the tangent of 225 degrees?
So that would be 45, and that be, wouldn't it be just root 2?
Okay, read the tangent from that. So
Oh,
Toa.
when we do it where the hypotenuse is always 1. Sorry.
Doesn't matter. I know. I ran into that also. And I understand why you do it that way. It's because you're dealing with the unit circle and the hypotenuse is always 1.
Yeah.
But it actually makes it harder to come up with these answers. And it doesn't change anything. In other words, if I make this 1 and this root 2 over 2, root 2 over 2, I'm still going to get the same ratios. It's just going to make it harder to figure out what they are. In other words, if I change my ratios to this thing to do what you suggested, okay?
Yeah.
Now, if you try to figure out the tangent of 30 degrees, you're going to have to take 1/2 divided by root 3 over 2, and then go through all the algebra to figure out what that is.
Yeah.
Whereas if you use the standard triangle that we've been using for years, you get the right ratio right away.
Yeah.
Well, you get 1 over 1 for tangent of 45 degrees.
Yeah.
Right? You see it?
Mm-hmm.
So it's equal to 1 with what sign in front? Plus or minus?
That would be minus. Oh, no, plus, because it's tangent. It's yeah.
Okay. Give me the cosine of 300 degrees.
It's going to be positive, and then that's 60, or no, 30. That's 30.
No, you were right. Use this formula right there.
Oh, yeah.
That's why it's there. Is whenever you have an angle that's in the fourth quadrant, subtract it from 360 to figure out what its equivalent first quadrant angle is.
Yeah. So it's positive and it's 60 degrees.
Which makes it value what?
Which means it's cosine is 1. It's 1 over 2.
Correct. And it's positive correctly.
Yeah.
Now, you don't have to think to do those. There's an old saying that I heard once that I really found quite good, and that is, you don't want to memorize trig. You want to learn it like you know your name. You don't memorize your name. When somebody says your name, you don't have to draw on your memory banks to answer.
Yeah.
You know it. It's instantaneous. That's how good you want to know trig. You do not want to have to think, well, cosine is adjacent over hypotenuse.
Yeah.
You want to know that right away. Same with sine, same with tangent. Now, the ones I do think on are the three, what I call the secondary trig functions. Cotangent, secant, and cosecant. There's nothing any more secondary about these. It's just that if you have a TI-84, you don't have these keys on it. So to figure out these three trig functions, you have to use the reciprocal properties. Well, what's the reciprocal of cotan?
Cotan would be the opposite, or adjacent over opposite.
Just what's the reciprocal? Yeah.
Yeah, so
it's tangent. Adjacent. That's what I was looking for. Cotan is 1 over tan.
Oh, okay, yeah.
Okay, which means that tan is 1 over cotan. In other words,
so when
important...
So when you put these in, could you put them as like tangent of the adjacent over opposite instead of, or
yeah, you can do that. Sure, you can definitely do that. In other words, if I said, what is the cotan of 30 degrees, you would do adjacent over opposite, which would be root 3. But if you're doing it in a calculator, what kind of calculator do you have?
I have a TI-83.
Okay, so if they said, what is the tangent of 29 degrees, you can get that in a calculator.
Yeah.
But if they say, what is the cotangent of 29 degrees, well, that is 1 over the tangent of 29 degrees. And this is the way you have to do it in your calculator, because there's no cotan key. So if you're doing odd angles, in other words, as long as you're talking angles that are some multiple of 30, 45, or 60, then you don't use your calculator. You use your knowledge of these two special triangles. But at some point, they'll give you angles that are not 30 degrees or 45. Like they'll say, what's the tan of 29? Where you can type that into your calculator, come up with a number. But if they say the cotan of 29, you have to know that the cotan is the reciprocal of the tan. And the only way to get this answer out of your calculator is to do 1 over the tan of 29 degrees.
Yeah.
So these reciprocal relationships are very important and will become more so. What's the reciprocal of secant?
Yeah.
What is it?
The cosecant?
No, it is cosine. And the
Oh, yeah.
reciprocal of cosecant is sine. So, let me give you a way to memorize these. First of all, this one is the only logical one.
Yeah.
You don't have to memorize that. Reciprocal
Yeah.
of tangents, cotangent, reciprocal of cotangents, tangent. Which means the only two you have to figure out are secant and cosecant.
Yeah.
Well, secant goes with cosine, cosecant goes with sine, and furthermore, all three of these relationships have precisely one co in them. So if you make a mistake and get secant with sine, you've done it wrong. There is no co anywhere there.
Yeah.
So that's not right. Okay, so once you put cotangent with tangent, then the other two are defined by the fact that there has to be a co in there. Okay, so that helps you memorize the reciprocal relationships. Now, just to be clear, there are also something called cofunctions. Have you talked about them yet?
No.
Well, let me go over them just so that I'm not going to confuse you by my things here. The cofunctions are the functions where you take the regular trig function, you stick a co in front of it. In other words, the cofunction of sine is cosine. The cofunction of tangent is cotangent. The cofunction of secant is cosecant. And what they share in common is this property. The sine of an angle is always equal to the cosine of 90 degrees minus the angle. Sorry, not pi.
Yeah.
X. In other words, if I said, what is the sine of 30 degrees, we know that that has to equal the same thing as the cosine of 60 degrees. And it does. They're both equal to 1/2. If I said 29 degrees, then that's going to equal the cosine of 61 degrees. So that's a fairly important property. You may not have learned it yet, but I wanted to mention it merely because when I use this little technique to teach people the reciprocal relationships, I don't want you to get that confused with the co-function relationships. Even though I tell you the way to memorize this is there's exactly one co in each pair, which is a true statement, but it's not the same relationships as the co-function relationships. Notice the co-function relationships are very straightforward. It's sine, cosine, tangent, cotangent, secant, cosecant. The only one that's the same is this one, the tangent, cotangent, is both a reciprocal relationship and a co-function relationship.
Yeah.
But if you haven't gotten to these yet, set this aside. You will get to that. But don't confuse it with the reciprocal relationships. It's the only thing that hesitates me giving people that memory trick that there's one co in each of these relationships.
Yeah.
All right. What is the sine of minus 30 degrees? And tell me if any of this stuff is new, if you haven't had negative angles.
I haven't had negative angles yet.
Okay. Let's talk about negative angles because you will be getting them really quick. Positive angles are measured counterclockwise from the x-axis. Negative angles are measured clockwise.
So would it be the same but negative?
Yes. Well, it depends on the function. In other words, trig functions are odd or even. Sine is odd.
Cosine is even.
And remember that odd functions are functions that if you take the function of negative x, you get negative the function. Even functions mean that if I take the function of a negative x, I get
Equals x.
exactly. Tangent is odd. Excuse me. And of course, each reciprocal shares the same property. So if sine is odd, then cosecant is odd. If cosine is even, then secant is even. Tangent's odd, cotangent's odd.
Yeah.
So when I said, what's the sine of minus 30 degrees, that's
Then
the
it would
same
be
as minus the sine of 30.
So it'd be negative 1/2.
Correct. Now, the other way to do that, but it's actually harder, is to convert it to a positive angle. In other words, find the coterminal angle of negative 30. Well, if I have a negative 30 angle like that, that's the same as a positive 330 degree angle. So
Yeah.
our answer should be the same as the sine of 330. And how would we get the sine of 330? We would say that's the same as the sine of 30, which is 1/2, but it's in the fourth quadrant, so it's negative.
Yeah.
So I come up with exactly the same answer, but it took me 2 extra steps to do it. In other words, it doesn't really make sense to convert this negative 30 degree angle to a 330 and then apply 360 minus theta to convert it back to a first quadrant angle and so forth. There's 2 extra steps required to do it that way, as opposed to just saying this. In other words, knowing whether it's odd or even, it saves you 2 steps. The moment I know that sine is odd, and I can say sine of minus 30 equals minus sine of 30, now I know minus 1/2 instantly. Also, cosine is even. What else do we know about even functions? They are symmetrical about the y-axis.
Yeah.
Well, notice this is symmetrical about the y-axis. That's the cosine function. If I said, what is the cosine of 30 degrees, it would be that point right there, right?
Yeah.
Well, if I said, what's the cosine of minus 30 degrees, it's still that same value. Because this curve is symmetrical with the y-axis. Whereas the sine is symmetrical with the origin, which is also a property of odd functions. There's sine. If I draw it on the other side of the axis, it looks like this. Now here, if I said the sine of 30 degrees, it's 1/2. But if I wanted the sine of minus 30 degrees, it's minus 1/2.
Yeah.
Is there any part of trig that we haven't reviewed that you need to review for whatever this next thing you have coming up is?
No, I think that covered everything, because logs, I think I have logs pretty well.
Okay.
And
Tell me the exponential expression of this. Hold on. Hold on. Let me finish.
Okay. So it would be 10 squared equals 100?
Yeah. In other words, with logs, the one thing you absolutely want to be able to do is to switch back and forth between logarithmic expression and exponential expression. If I told you that 10 squared equals 100, you need to be able to put that into a log statement. Or if I told you this, you need to put it into its exponential expression.
Yeah.
All right, I can't think of anything else with trig that you would need.
Yeah, I think I'm pretty good for this
Okay.
upcoming thing.
Well, why don't we call it a session here?
All right, sounds good.
We'll meet again next week. Lucas, have a good week.
You do.
Bye-bye.
Bye.